In this video, we are continuing our quiz 2 review and gonna look at an example involving some permutations, combinations, and complements. So the example says that there are 9 new and 15 experienced players trying out for a Quidditch team whose roster consists of 7 players. How many ways are there to select the roster? Part A asks, with no restrictions. And then part B of this question, I'm going to state as well, says if the positions of these 7 players are keeper, seeker, left chaser, center chaser, right chaser, left beater, and right beater. And this one says don't simplify your answer. So this is a question from the world of Harry Potter. So I want to begin by giving you all the opportunity to pause the video for 3 minutes to try both part A and part B. 4, 3, 2, 1. Pause that video. Pause it for 3 minutes to try both A and part B. All right, so hopefully you've done that. Hopefully you paused the video to try both of these questions. So let's talk about it together. Part A says there's no restrictions when we're picking our roster of 7 players. So the first thing is let's count how many total players we have. It says there's 9 new and 15 experienced players, and if we add those together, there's 24 total players. And A says there's no restrictions when we're picking these people, which means, so we are picking any 7 of the 24 total. And as we do that, the order does not matter. And because the order does not matter, that should make us think of combinations rather than permutations. So combinations. In fact, we need to choose 7 members from a group of 24. So I write this as, with my narrow parentheses notation for combinations, I would write 24 up here, 7 down here. And the way I say this in words is this is 24, choose 7. Okay, and to work out what this is, I could use my formula for combinations. So one of my formulas that's purely in factorial form would give me 24 factorial on the top over 7 factorial on the bottom, and then also 24 minus 7 factorial. And if we work out what this is with a calculator, we get 346,104 ways. And that's our answer. So in part B of this question, it says that there are positions for these 7 players. Okay, so there are now 7 distinct positions. So when we think about, if we were to put slots for all of them, 1, 2, 3, 4. Actually, let me do that underneath. Let me do that underneath to give myself some more room. If I were to put slots for all of these people, 1, 2, 3, 4, 5, 6, 7, and then label the positions. So let's put K for keeper, S for seeker, left chaser, LC, center chaser, CC, RC for right chaser, LB for left beater, and let's do RB for right beater. So the 7 positions. So when I think about who to put in this first position and then who to put in that second position, the order definitely matters. Because whoever I put in that first spot is going to be the keeper, whereas whoever I put in the last spot is going to be the right beater. Okay, so there's 24 total people in this problem. So if I go from left to right, there are 24 choices for who to pick in that keeper position. And once I pick who's in that keeper position, there are 23 ways to pick who goes in the seeker position. And once I've picked those 2, now there's 22 people left to pick the left chaser, and so on. It's going to keep going down by 1 each time. So this is times 21, and then times 20, times 19 times 18. So if I just write this out, this is 24 times 23 times 22 times 21 times 20 times 19 times 18. And this question said don't simplify your answer, so it's fine if I leave it like this. That is my answer right there. So one thing that you may have been thinking is, in this question, the order matters. So that means, isn't this a permutation? And absolutely, this is a permutation. We are picking a group of 7 people from a larger group of 24, and the order in which we pick those 7 matters. So we can also write this expression as using our notation for permutations. This would be P of 24, 7. We could also write that with that notation for permutations. Alrighty, let's move on to part C of this question, which now says, now let's say that the positions are keeper, seeker. There's 3 chasers, so we're not distinguishing what's the left one, the center one, and the right one. 3 chasers and 2 beaters. And as well, the beaters are identical. There's no left beater and right beater, just 2 beaters. And don't simplify your answer. Okay, so pause the video for this time for 2 to 3 minutes to try this question. 4, 3, 2, 1. Pause that video. Pause it for 2 to 3 minutes to try this question. Alright, so hopefully you did that. Hopefully you paused it and tried this for about 2 to 3 minutes. In general, with these quiz review videos, I'm giving you more time to pause the videos to try each question. So when I go through the solution, I'm going to go through it a little bit more quickly than I usually would. Alright, so let's talk about the strategy for this one, because it's slightly different than the previous question. Alright, so I can think about this in stages. First, let's pick the keeper. Next, maybe we'll pick the seeker. Because there's only one of each of those, so it seems like maybe it's easier to pick those. And then maybe next we'll pick the 3 chasers. And then finally, we'll pick the 2 beaters. Okay, so let's take these on. So for picking the keeper first, well, there's 24 total players. So there's 24 ways to pick one of them to be the keeper. All right, so once we pick the keeper, now there's 23 people. I'm just going to write PPL left. 23 people left. So we're going to pick one of those 23 to be the seeker. So there's 23 ways to pick the seeker. Okay, and at this point, we have now picked a keeper and a seeker. So we've picked 2 players. So there are 22 people left. And when we pick the 3 chasers, their positions, their roles are identical to each other. So the order in which we pick the 3 chasers does not matter. Similarly for the beaters, their positions are identical. So the order in which you pick them does not matter. So for 3 and 4, the order does not matter for both of these. So that makes us think we're going to use combinations for both of them. Okay, so for picking the 3 chasers, we got to choose 3 people out of the 22 that are left. So we do that in 22, choose 3 ways. And then after we've picked those 3 chasers, so we'll work out what 22 choose 3 is a little bit below. But after you've picked 3 people to now be chasers, now there are, let's see, there were 22 people left before, and you've picked 3 of them to be chasers, so 22 minus 3. There's 19 people left. And then finally, we got to pick 2 of them to be beaters, and the order in which you do it doesn't matter. So there's 19, choose 2 ways to pick the 2 beaters. So ultimately, we can write down our answer, we would multiply these values together. So it would be 24 times 23 times 22, choose 3. Let's just practice using our other formula for combinations that doesn't just have all factorials. So because I'm picking 3 people here, I start off with a product and do 22, and I descend times 21, and I keep going until I have 3 total things in the product. So 20, because I'm picking 3 things. And then I divide that by 3 factorial. This was one of our formulas for these combinations. Similarly, if I did the same type of thing for 19, choose 2, we'd have to have a product of 2 terms on the top because we're choosing 2 items. So we'd get 19 times 18 if I start to descend. And then on the bottom, I divide by 2 factorial. Okay, so the 22, choose 3, that matches up with this fraction. And the 19, choose 2 matches up with this fraction. And part C said don't simplify your answer. So it is okay to leave our answer like this. So let's do one more part to this problem. So in part D, it wants us to find the number of ways to pick our roster if the team must have both new and experienced members. So we don't care about positions here, we just need to pick the 7 members. But the team must have both new and experienced members. And remember the question said there were 9 new players and 15 experienced ones. So start off by pausing the video for this time 3 to 4 minutes to try this question. 4, 3, 2, 1, pause that video. Pause it and try this one for at least 3 to 4 minutes. Alrighty, let's talk about this one together. So there are 2 maybe most natural approaches we could take to this. So I'm going to talk about both of them. So approach 1 would be to count this directly. So it would involve thinking about what are all the different ways we could make sure we have at least 1 new member, at least 1 experienced member on the team. So we would have to think about various cases. So for example, one way to do that is if we had 1 new member, I'll just write 1n, and 6 experienced members, so I'll just write 6e for that. Okay, but another way is if you had 2 new members and 5 experienced members, because that would add up to 7 total as well. And we could keep going like this. We could keep increasing the number of new people by 1 each time and decreasing experienced. So eventually, we end up with 6 total cases here. The last one is, what if you have 6 new members and 1 experienced person? Okay, so we have other cases that we could fill out, and we could work out all of these. So this is definitely doable, but it's tedious. It would be tedious if I had to write out all 6 of these and evaluate them. So it would be nice if there was some other way to do this. And that is what approach 2 is going to be all about. So sometimes when it's hard to count an object directly or it's a bit tedious, we can think about using complements and instead counting the opposite of what it is the question wants us to find, and maybe that ends up being quicker. Okay, so let's think about how we would do that. So we want to find the number of possible teams we could have with both a new player, which I'll just call N, and an experienced player, which I'll label E. So using complements, this is going to be equal to the number of total possible teams without any restrictions, and then we would subtract away the number of elements in the complement. So the complement of the set of teams with both new members and experienced members, the opposite of that would be, well, teams, let me write this better, teams either with all new members or with all experienced, I'll just write EXP, experienced members. Okay, so let's think about this. For the number of total possible teams, we just need to choose 7 members out of the 24 total that we have. So this is going to be 24, choose 7. Okay, and now we need to count the number of teams that either have all new members or that have all experienced members. So let's simplify that. Let's put minus and let's put a bracket. Now let's simplify this number of teams here. So we can count this by finding the number of teams with all new members, I'll try all n, and then add that to the number of teams with all experienced members. Because these two sets, teams with all new members and teams with all experienced members, these are disjoint. So that's why we can just split it up and add like this. When we have this word or, it's a union actually that we have here. Alrighty, so we are almost there. So we have 24, choose 7, and then minus bracket. So if you have a team with all new members, remember there's 9 new members. So we'd have to pick our 7 members from those 9. So that would give us, let's see, we'd have 9, choose 7. And then plus, if you're picking the team with all experienced members, well, there's 15 total experienced members. So we'd get 15, choose 7. 15, choose 7. And then if we do stuff like distribute the negative sign to both of these terms, and if we simplify this, we'll end up with 339,633. Well, if we use like the formula for these combinations and simplify it. Alrighty, so that is it for this video. In the next video, we will do some more review and talk about adjusting for overcounting.